All right, guys, we're up for another video. Let me set you in place and then we're all ready to go. Alrighty, so here we go. Substitution. Now, I told you, or I might have told you, just like there's three types of solutions, there's three ways to solve systems of equations. The first solution, remember, is parallel lines, and that means no solution. When they cross somewhere at any point, it's one solution. And then if they are the same exact line and they lie directly on top of each other, then it's an infinite amount, because this could be a solution here, then here, then here, then here, all the way down. Well, today we're going to look at substitution. All right, so you have your notes in front of you, and it says, to solve a system of equations using the substitution method, you need to solve one of the equations for one of the variables. Okay, remember, system of equations is going to have multiple variables. And then substitute the expression for the variable into the other equation. Now, I'm going to kind of talk while you copy this down. Think of substitution like a substitute. What happens when Miss Budens is not in school? Well, a substitute comes in and teaches, because if I let you be by yourself, you would run crazy. Or Shipley would try and take over. Or Sakib would try and take over. Anyways, it would be complete chaos, all right? So we have a substitute come in. Substitution, therefore, you can think of just like a sub. We can replace it temporarily because, remember, Miss B's not going to be gone forever. She comes back. And then we figure out what we're supposed to do, and then Miss B comes back. So I think the best way you're going to understand this is by looking at the example. So here are my two systems of equations. We've got y equals 2x plus 3 and 2x minus 2y equals 4. All right. So the first thing I'm going to do is I'm going to pick one to substitute in for. Now, if this were in standard notation, I would have to convert one of these into slope-intercept form. But because this is here, it's telling me that y is equal to the 2x plus 3. So what I can do is I can actually substitute this in for y, which I'm going to do over here. So I'm going to take the 2x minus 2 times 2x plus 3, and that I'm going to set equal to 4. All right? All I did was I dropped this in for where y was, because y equals 2x plus 3. Now I'm working with only one variable, which makes it way easier. So what am I going to do? Well, I'm going to distribute and then simplify. I'm going to distribute the 2 here and to our second number. That's where people mess up a lot. All right, so we keep the 2x, all right? Then we get minus, well, negative 2 times 2x is minus 4x. Negative 2 times 3 is minus 6 equals 4. I'm going to combine my like terms, which are, I have 2 x's. Remember, we take it in front. And then I have a 6 and I have a 4. So 2x minus 4x is negative 2x. And then if I add my 6x to both sides, I get 10x on this side. Next, I need to isolate the variable, which means get x alone. So I'm going to divide both sides by negative 2. That gets rid of the 2. I'm left with just x. And then I find out that 10 divided by 2, -2, is -5. Pardon my phone. All right, so now I know what one of the variables equals. X equals -5. Easy peasy lemon squeezy, right? All I have to do then is plug that back in, then substitute the expression for the variable into the other equation. So since I use this one to find my x, I'm going to go back here, although it really doesn't matter which one, but it's easier to plug in here. I'm going to say y equals 2 times, well, what is x? -5 plus 3. So let me write my -5 in, because that's equal to x, and this is where the x is. Well, if I simplify this, I'll get y equals 2 times -5 is -10 plus 3. -10 plus 3, y is going to equal -7. So my solution to this problem, if I put it in a point type answer, is going to be -5, -7. And if I were to graph these two equations to double check, they would cross at -5, -7. So first, I need to do the following, and this correlates with your notes. You need to substitute 2x plus 3 for y. All right, we did that here. Then we used the distributive property, which we did, to get 2x minus 4x minus 6 equals 4. Then we need to add 6 to both sides. Add 6. Then we need to divide each side by 2, which we did, to get x equals -5. All right. Then we take our -5, we plug it back in here into our first equation. 2 times -5 plus 3, we get to equal 7. So we substitute -5 in for x, and we get -7. Now I can check this by plugging in -5 and -7 into both sides of the equation. So let me quick show you this. So our answer was the point -5, -7. So if I took my y equals 2x plus 3, and if I took my 2x minus 2y equals 4, they should equal each other. Well, remember x, y, so -7 should equal the same as 2 times -5 plus 3. -7 equals 2 times -5 is -10 plus 3. -7 equals -7. It checks. Now I can come over here. 2 times -5 minus 2 times -7 should equal 4. This is going to be -10 minus, well, -10 negative is actually positive, plus 14 should equal 4. All right, -10 plus 14 is 4. 4 equals 4, so it checks. You can fill that in on your notes. All right, what I want you to do now is I want you to try the quick check on your own. Try the substitution method, and if it doesn't work, that's fine. Raise your hand, and I will come help you. Then we're going to practice some more. All right, have a great rest of your day and class. I'll see you later. Bye.